we have the recording now going now. And so we'll go into a little bit of detail about the molar masses that we're working with today. So I'm going to share my screen with you. So let me do that. Okay, so these are different compounds that are all hydrates. Can you see my screen?
Yes, ma'am.
Okay, thank you. So here we've got these different molar masses. And the sort of what we generally do with molar masses is always record them to 2 decimal places. That's just sort of a general rule. Take your molar masses to 2 decimal places. So in getting these, you used your periodic table. For the first one, you looked up barium and then bromine, and we put down the atomic mass of bromine, doubled it because we have 2 of those. And then at the end, the easiest way to do this lab, because of what you had to do after getting the molar masses, is say, if you were to add 1 oxygen and 2 hydrogens, you would come up with the number 18.02 grams per mole. And so instead of doing hydrogens and oxygens separately, you can speed the process up and say 18.02 is my molar mass of 1 water molecule. So if I double 18.02, I get 36.04, and I'll add that in with my barium and bromide part of the molecule. And the advantage on doing it that way for today's lab is you have to use that water component, in this case 36.04, and divide that water component by the whole molar mass, then multiply it by 100 to get the percent waters for each of these compounds. And those percent waters are a key to what we're doing today, because we'll use the percent water, you will use the percent water to determine which one of these compounds you have that's an unknown. So it's labeled on your jar unknown 11, in the information you're given for today's lab, unknown 11. It's one of these, and it's your task to determine which one of these it is. And so we'll walk through the process that we're going to use to determine which of these compounds it is. Okay, so let me share with you the other document that I want to share, and that is the percent hydrate. So this table is another one that you completed before coming to lab. It was part of your pre-lab. And so you'll be using this table at the end of lab, because at the end of the lab, you will have calculated a percent water. And frankly, it will fall between, it won't be exactly any one of these numbers, but it will fall, your percent water that you calculate will fall between 2 of these numbers. And just to have one for a point of discussion, let's say that it falls between these 2 numbers right here. Let's say it falls between 14.8 and 20.9. So let's say it's 17.8, pretty much halfway between those 2. If it's 17.8, and even if it were closer to one than the other, this is what I want you to think. And I'm going to ask a question that I want you to respond to here. If it's 17.8, would it be possible, we know it's between these 2 compounds, the barium chloride and the calcium sulfate, would it be possible for me to get more water out of my unknown compound than what this theoretical number or this true number is? Could I get 17% water out of a compound that only had 14.8% water in it? What do you think? Anybody?
No. I'm sorry, ma'am. You cut out for me. Could you repeat that?
Wait just 1 minute, because I unfortunately have my speakers way down. Tell me again what you just said, please.
You cut out for me. I couldn't hear your question.
You could not hear my question.
No, ma'am.
Okay, I am sorry. Can you hear me better now?
Yes, ma'am.
Have I been talking in a way that you could not hear me up till now?
No, ma'am. You just cut out for a minute.
Okay, good. I'm glad. Or I'm not glad I cut out, but I'm glad that you could hear me up to this point. So here's the question. This is hypothetical, but let's say that you've done your calculations in today's lab and you're to the point where you've determined the percent water in the hydrate. And in doing so, we're just to have something to work with. We're saying that you got between 14.8 and 20.9. You're between those two numbers on this list of different percentages. And so what we hypothetically said is that you had 17.8% water, so that you were pretty close to dead between those two numbers. But even if you were not dead between the two numbers, there's something that we want to talk about and that comes into play. It's a major factor in today's lab. Is if we were to have 17.8% water, and numerically we're pretty much between these two compounds, deciding between these two compounds as our unknown. There's another factor that comes into play in this decision, and it's this. If we have 17.8% water, can we consider a compound that has less water than the number that we're getting as the amount of water in the hydrate? Is that possible? That's the question. And that's the question you're going to need to answer in this lab. So give me your thinking on that. These are theoretical, or another way of using the term would be, these are the true values. I mean, we've determined these using the atomic masses on the periodic chart. These are the real numbers. This is how much water is in that compound. If I have 17% water, would either of these two up here be a possibility? Anybody?
No.
No.
No is right. We cannot manufacture water when we're heating these compounds. We will not. All we're doing is evaporating the water off. What may happen, and what happened in that lab today with the pictures you're watching, is all the water wasn't driven off. The hot plate, it based on the numbers and what probably happened, the hot plate wasn't hot enough to drive off all the water. And so some of the water in that compound, in this case, we're between these two numbers, likely it's this one. And all the water wasn't driven off. We know it cannot be this one, because we know that we're not going to have more water there than is chemically possible to have there. So you'll address that at the end of today's lab, because you'll be in that very same position of deciding, well, I'm between these two, which one should I choose? And that's the logic you need to use. Okay, any question about that?
No, ma'am.
Okay, let's go to the document that you will spend most of your time in lab today with, and it's this one right here. It's one of the links in your series of links for today's lab. And it's the link that's labeled Hydrated Salts Lab Procedure with Pictures. This is the place you want to start, and this is the place the bulk of your time will be spent in today's lab. And so let's talk through this a little bit and make sure that when you get in your breakout rooms, you'll have a pretty good understanding of what's involved and what's happening with the lab. And so the unknown number we've already mentioned, it's here on the jar, and you'll simply record right here. It says hydrate unknown number, and you'll simply record that number that's there on the jar. And then it says the mass of the empty evaporating dish, and the evaporating dish is this thing right here. And so as you can see, it's on the balance, and as you can see, there's a number there. Now, what is not real clear, but I want you to be aware of, is anytime you're using this kind of balance, and this is what we always use in Chemistry 1010 labs, there's always going to be 2 decimal places. So even though that decimal is sort of hard to tell where it is, there will always be 2 numbers after a decimal with this balance. So in this case, you will know that that's 23.93 grams. And the rule is, as I know you already know, because Dr. Cook will have talked about it in previous labs, is you always record every digit on a digital balance. So you're recording on that table 23.93, and you'll always put units, and it's a little g here for grams. So you'll record that in the space provided up here for mass of empty evaporating dish. Now the third one, and these numbers go directly with the information down here. The third one, if you wanted to go directly to number 3 in this series of pictures, that would be where the mass of the evaporating dish and hydrate would be. So this is from number 2 to number 3, hydrate was placed into that evaporating dish, and then it was placed on the balance, and you again will read that balance and record the mass right here. And again, make certain that you record the 2 decimal places. You must record every digit on the digital balance. Now, this is where I want to get some input from you. Mass of the hydrate, and it tells you it's not a picture that you look at and record, it's something that you calculate. So knowing that up here above, we have the mass of the evaporating dish and the hydrate, and then we have a number for just the mass of the empty evaporating dish. How do you think I would get the answer to number 4, mass of the hydrate only? Somebody tell me that.
Subtract the evaporating dish.
Exactly. We subtract the empty evaporating dish from the mass of the evaporating dish and hydrate, and that will give us this number. It's going to be in the ballpark of 2 grams, but you'll have 2 decimal places with that. So you want to record exactly what that mass is to 2 decimal places. Now, the next thing here is mass of evaporating dish and sample after the first heating. So as you can see here, there's 2 separate heatings. The first heating is done thinking that at the end of the first heating that all the water has been driven off from that hydrate. But in order to confirm that all the water is driven off, a second heating is done. And so these 2 numbers generally are pretty close together. And in this lab today, they're very close together, showing that yes, almost all the water was driven off in the first heating. Just a very, very, very small amount was driven off after it was put back on the hot plate a second time. So this number right here then is a number 11, represents what we call the anhydrate, the compound without water, and the evaporating dish. So it's the mass of the evaporating dish and the anhydrate. Now, right down here, the very next question, and it shows us in parentheses, we have to calculate this. It's not a picture you look at and get the mass from a balance, but the mass of the anhydrous compound, it's another way of saying the anhydrate. We want just the mass of the anhydrate. Right up here, we've got the mass of the evaporating dish and the anhydrate. So how am I going to get the mass of the anhydrous compound? Anybody?
Subtract the evaporating dish.
That's exactly right. I'm going to take number 11 and I'm going to subtract that evaporating dish right up here. I'm going to subtract the number 2 mass from it, and I will have the mass of the anhydrate. Okay, now this one right here, let's get one more down. It's number 13, and it says the mass of water in the hydrate. Mass of water, and it tells us we've got to calculate it. We obviously don't measure that water as it's evaporating off there in the atmosphere, but we have enough numbers that we can figure it out. What 2 numbers would we use to determine the mass of water in the hydrate? We've got the mass of the anhydrate. That means the mass of the compound without water in it. And up here, we've got the mass of the hydrate, the mass of the compound with water.
So you would subtract the anhydrate and the dish, and whatever's left would be what's left of the water?
Okay, you're thinking right, but it's a little bit simpler than that because of the calculations we've already done. So if we know that the only difference in a hydrate and an anhydrate is water. So up here before, we got the mass of just the anhydrate right there, number 12. We have just the anhydrate right there. And up here, because of the calculation we've already done, we've got the mass of the hydrate. So knowing that the only difference in those 2 is water, all you have to do is get the difference in those 2 numbers, and you'll have the mass of water. Get the difference in number 12 and number 4. The only difference in an anhydrate and a hydrate for a specific compound is water. So if you have those 2 numbers, you get the difference in them, then you've got the mass of water. And then that last one, percent water in your sample. So if we have grams of water right there, how am I going to determine percent of water in the sample?
Divide.
That's exactly right. I'm going to divide. And the rule, anytime you determine the percent of apples, the percent of anything, the rule is this: part, in this case, water is our part, divided by whole. In this case, our whole is up here at the very beginning, the mass of the hydrate. That's the whole sample. It's a sample with water in it. So the part I want to know is what part of it's water. So I get my mass of my water from number 13 and divide it by my mass of hydrate, number 4. That's my whole. Part divided by whole times 100 will always, anytime you want to know percent of anything, that's the formula. Part divided by whole times 100. And then it asks for the formula of your unknown hydrate. So what you'll do at that point is look at that table that you have and that I put up earlier in today's lab, and you'll be between 2 of those numbers, and you'll decide, based on our discussion earlier, you'll decide which unknown you have. And then by that time, Dr. Cook will be back and she can make sure that you're on the right track on all this. But notice here, question 16 asks that you explain why you chose the hydrate that you chose. And so remember the conversation we had at the front end of lab, because there's a couple of things you want to put here, not just one. So put both things as you explain that. Okay, now, do you have any questions? Okay, so this is a point at which you are free to go to the breakout rooms and work on that document that we said that you want to work on, the one with procedure and pictures. That's the one that will be the thrust of today's lab. Once you've got that completed, then you can get on the electronic document that you each will submit individually and that will count as your grade. You won't get back a grade immediately because there's a part of it that has to be hand graded by Dr. Cook. And so you can go ahead and submit it, but I would suggest check with her before you submit to make sure that everything's right. This is not like it was recently where you can submit it as many times as you want to. This is only one-time submission. So make sure that you can if you have any questions, double check with Dr. Cook before you submit that so that things can be like they need to be and you can get a good grade on today's report. Do you have any, well, let me ask you a question before I ask you. Does Dr. Cook let you go into any breakout room you want to go into? Is that the way that generally works?
We already know the ones that we're in. There are a couple of us that got all mixed up at the beginning of the year and have just kind of stayed in the one, and she hadn't said anything.
Okay, so let's just do it like like it's always done. The one thing Dr. Cook did mention to me is if anybody wanted to work independently, they could. And so I guess if you work independently, you'll do it in the same manner that you've done it in the past. So at this point, if anybody have any questions about anything.
Could you go over the two reasons as to why we chose which unknown compound we chose? I remember one of the reasons being it's obvious if you have more water than a hydrate.
Yes, exactly. You could say something along the lines of, and let me put that picture because it helps to have something to refer to. So, let me go back through the proper process here. Share screen. Okay, so whenever and I'll stick with the example that we worked with. When you end up with your percent water that you calculate from your sample, it will be between two numbers. And we just have to, we said we're going to work with these two. And so you will narrow down the identity of your hydrate based on the percent water. And so you will determine that it's either, in this example, either barium chloride hydrate or calcium sulfate hydrate. And then for the last part of it, you have to deal with the fact that the true value of barium chloride is 14.8% water. That's the water that's in that compound. 14.8% of it is water. So if we ended up with, and the example we gave was 17.8% water, we know that it is not barium chloride, that it has to be this copper sulfate one, because we know we cannot get more water out of a compound. More water could not have evaporated from that evaporating dish, from that hydrate, than the water than the true value of water. That is the true value. That is the amount of water in that compound. So that nixes this one, because theoretically it is, in actuality, we don't produce water. All we're doing is driving water off. And we did not, most likely, that hot plate wasn't set high enough to drive off all the water, because it was left on the hot plate another 5 minutes, I think is what that procedure tells you. And that's long enough that last little bit that more water would have been driven off if it had been set on a higher setting. And whenever we're on ground, what we do is tell students to put that hot plate up to the maximum setting. And if you have it up on the maximum setting, all that water is driven off and you're very close to the real numbers. But in that example, when it was done, probably because of time, because everything's been rushed because it's online instead of on ground. And so the numbers are what they are, but at times you don't get real good numbers. And so you have to deal with the reality of, I'm not going to get a number I'm not going to get more water than is what is actually in the compound. That's the gist of it.
And
You
were saying to include 2 reasons though. So would the other reason being time on the hot plate?
Oh, the other reason is that the numbers give us the numbers narrow it down. We know based on the numbers it's right in this ballpark. So the numbers the percent calculation of water, that it's one of these two, and then the other is just what's possible based on the fact that the true value is what it is. But yeah, the numbers are your guide, and that's the reason you do all of today's lab up until the very end. Everything is number. What are the numbers? And that's because that's your major guide. That allows you to get it down to these 2 compounds or whichever 2 you're dealing with. And then the last little bit you think about, well, I can't have more water than is really there. But yeah, the numbers that you calculate lead you to that number.
Okay, thank you very much.
Other questions?
Can you explain one more time how you found the mass of just the anhydrate?
I'll be glad to. So let me get back to that one. Mass of the anhydrate. So right here, mass of anhydrous compound, that's number 12. Mass of the anhydrous compound. So right up here above it, we've got the mass of the evaporating dish and the anhydrate, or the anhydrous compound. That we've heated it 2 times. We've driven off all the water. So number 11 is the mass of the evaporating dish and the anhydrate. Number 12 says we don't care about the evaporating dish. What is the mass of the anhydrate? So what do you think you might do to get number 12?
I know you need to subtract the evaporating dish, but I was just wondering if that was a calculation you had to do, or if there was a picture of the total after it evaporated.
No. Oh, well, yeah. There's a picture of it after it evaporated right here in number 11. That's the one that you're going to get the picture of, but it's still in the evaporating dish. So you have to, you're right, you have to subtract the evaporating dish from it. The only picture is with it in the evaporating dish. And so you have to do that calculation. It looks, some of them look a little bit differently whenever the water's driven off. They're more powdery, less crystalline. So they look a little bit different, and that particular, this one that's in this jar, it looks pretty powdery at the beginning and it will look powdery at the end. Some of them, a lot of hydrates, if they have color to them, there'll be a different color after the water's driven off of them. Okay, good questions. Other questions?
So I just want to make sure I'm understanding how we submit the lab report for this lab.
Okay, good question. Let me see. I am going to click over here on eLearn. Oops, let me just a moment. Okay, right over here, this is my eLearn page, and it might have a little bit more than yours, but still yours will have this Hydrated Salts Lab Report. So once you do that document up here, Hydrated Salts Lab Procedure with pictures, that's where most of your time is going to be spent. But once you get those, that table filled out with that, going through those different pictures in that document, then you have what you need for this document. So once you get that done, come down here to Hydrated Salts Lab Report. Open that up and complete using your table that you got up here. Then fill in the answers here. And this is what you'll submit for your grade. Hydrated Salts Lab Report, this document right here. You'll submit that for your grade. And remember, you only get one submission. Dr. Cook will be back around 10. So double check with her if you have any questions about anything, because this is one submission. And frankly, there's no reason not to submit it today before you leave. Be done with it. Don't forget it. You can mean to do it later, and sometimes Friday at 11:59 flips by before you've done it. So I would encourage you. I know of no reason to not, once you've got that table done up here, to open this document, get it in there, answer the questions, submit it, and be done with it. I would suggest though, check with Dr. Cook if you have any questions about anything before you submit it, because once you submit it, it's gone. You've done it. You completed the lab. Okay, good question, because I hadn't brought that up at all, but yep, it's this document right here. You're a good group as far as asking questions that are pertinent and that other students would have the same question as you have. So appreciate the questions you're asking. Other questions? Okay, I'm going to let you go to those breakout rooms. If you have questions while you're in there working, I'm going to be here for the next 25 minutes or so. So don't hesitate to get my attention. My name is and I guess you do need to know that. My name is Boostabad, Jane Boostabad. So Mrs. Boostabad, if you'll type in Boostabad, or I'll swing back through. I'll tell you what, I'll swing through after a little bit, make sure that you don't have questions, because that's going to be the easier way to deal with it, I think. Or you can come back to general and get me. Okay?
Thank you.
Uh-huh.